Okay, so here's 1.3, question number 1. They're giving me a point on the terminal side of an angle. They want me to find the sine of theta. All right, well, what they're saying is if you draw an axis system, back 4, up 3 is right there. So back 4, up 3, right? That's an X and a Y. Y'all with me? This is the point. Back 4, up 3, that dot right there. And you always put your angle, I should probably make that a little bigger. Let me make that a little bigger. You always put your angle in the center. So one more time. This is X and Y. That's a 3 there. X and Y. Back 4, 2, 3, 4, up 3. Back 4, up 3. Back 4 on the X, up 3 on the Y. Like that. And here's your angle theta. You always put that right at the center. Notice you don't put it up here or anywhere else. You always put it right at the origin. See how that theta is right there at the origin. Okay. And they're asking me for the sine of theta. How do I find sine of theta? Now, I know this could seem very confusing because of all that I just did with the unit circle, right? You think, well, what do you do all of a sudden, Mr. Andrew? You're supposed to do the unit circle thing. No, I know this probably is confusing. This one is not a unit circle. It'll make more sense as we go. How do I know this is not a unit circle?
There's no degrees?
They didn't give me degrees, but yeah, that's true. Yeah, if they just gave me sine of 30 degrees or whatever, then yeah, I would use the unit circle. You're totally right. That's true. Another way is I'm gonna. Well, let me say what I do. I use SOHCAHTOA. You do it with SOHCAHTOA. So what do I mean? Sine. I'm trying to find sine. So that's what? What is sine going to equal? Sine of theta. Opposite over hypotenuse, right? SOHCAHTOA. Opposite over hypotenuse. So if this is angle theta in my little triangle, which side is the opposite side? Yeah, the 3 is the opposite. This is the adjacent. This is next theta. And this side's the hypotenuse, huh? So I need opposite over hypotenuse. I've got the opposite, that's 3, but I don't have the hypotenuse. Right here. I don't know what it is. Can I find it? How do I find that hypotenuse? Pythagorean Theorem. Yeah, remember the Pythagorean Theorem? A squared plus B squared is C squared. So the C squared is the hypotenuse, right? The one, whenever you do this, the hypotenuse is the C. The A and the B, doesn't matter what order they're in, they're interchangeable. But the C is hypotenuse, that's the one alone. So 3 squared plus 4 squared. I don't know if you remember. Well, anybody know already the answer?
Well, it doesn't have to be. Does it have to be negative 4?
Oh, it doesn't matter. Because what's the difference between negative 4 squared and positive 4 squared? It's going to be 16 either way. Yeah, that's why I'm being casual about it. Because it doesn't matter. This is 25. Like that. And root it, 5. And by the way, that's a good one to memorize, 3, 4, 5. 3, 4, 5 comes up a lot. So you can, if you know that, you can just skip the work and go, oh, I know it's 5, 3, 4, 5. They use that one in 5, 12, 13. If you want to, those are called Pythagorean triples. 5, 12, 13, and 3, 4, 5 come up a lot. You want to just remember those. Save you some work. Anyway, so the hypotenuse is 5, 3/5, done. We found the sine. What is the sine? Opposite over hypotenuse. The opposite is 3. The hypotenuse is 5. 3/5. Now, why couldn't I have done the whole, what about my whole unit circle thing? Well, this is not, you see if I drew the circle here, what's the radius of this circle? 5, not 1. That's why I couldn't do the unit circle. Now, this is rare. They're going to give me like 3 of these. And then never again in the course. I mean, the rest of the course is going to be unit circle. So that really is the main attraction, what we're going to mainly be doing. This is just kind of a weird problem where you got to draw a little triangle and find the hypotenuse, and the hypotenuse is not 1. So those values I gave you, the small, medium, large, root 1, root 2, root 3 over 2, that's only on a unit circle, radius 1 circle. Those aren't true on bigger circles or other circles. This is a radius 5 circle. That's why I can't do any of that stuff. So I just draw the triangle, find the hypotenuse with a squared, b squared, c squared, and use SOHCAHTOA to find it. How do I find the other three? So one more time, I just found cosine, because cosine is adjacent. This is adjacent over hypotenuse, right? Adjacent over hypotenuse. And tangent is opposite over adjacent. TOA, opposite over adjacent. So that was opposite 3 over adjacent, negative 4. And now, the other three trig functions, once you have sine, cosine, and tangent, how do you find the other three? You just flip it, huh? They're upside down, upside down. So flip this one. Cosecant would be 5/3. You can write these on your 3x5 card if you're having trouble remembering which are which. Secant is upside down to cosine. So negative 5/4. It still stays negative. We don't change any signs. We just flip the fraction upside down. And cotan, again, we don't change. If it's negative, it's negative. And by the way, it doesn't matter where a negative is on a fraction. I don't know if you know that. Doesn't matter. Bottom, top, front, whatever. One negative is negative. Doesn't matter where it sits. So just flip it and keep the negative. Anywhere you want. Top, bottom, front, whatever. It's all the same. So there we go. We found all 6 trig functions. Have you noticed once you've got sine and cosine, the other ones all come. That's why on that unit circle, when I showed you how to find sine and cosine, I was giving you everything. Because if you have sine and cosine, the other ones all come from sine and cosine. It's all about sine and cosine. All of trig is sine and cosine, really. All the rest is just the Johnny-come-latelys that flow after sine and cosine. So this is back to the unit circle now. Now we're back. How do you know? Because they're giving me an angle, right? They're not telling me a side. See how? Yeah. Let me make that more clear. See how in this problem they told me a particular x and y. So that was not a unit circle problem. That was back 4, up 3, which is a specific triangle, not in the unit circle. But this one, they're not giving me any x's or y's. They're just giving me an angle. Everybody see that? That's a lot of the battle in a math class, isn't it? All the problems can start to seem the same. So you want to spend time saying, you try to identify the different unique characteristics. They're just giving me an angle here. So they just want sine of pi over 2. What I would do is stick in a 180. Remember, pi is 180. So this is sine of 180 over 2, which is sine of 90. All right, let's draw the unit circle. Can you do it? So go ahead, let me let you, rather than me just whip it out. Put the dot at 90 degrees. Put the dot at 90 degrees and find the x and y coordinates at that point. And see if you can remember if sine is x or sine is y. Give that a try. Feel free to check with those that are around you. Okay, so 90's up here. That's 90 degrees right there, huh? Straight up. And what are the coordinates of that point? From the origin, how far over, how far up or down? Over 0, up 1? So that's a unit circle. The radius is 1, right? So this is cosine and sine. They're reversed by common agreement. So what do they want? Sine? Sine to 90? 1. Don't need a calculator, right? You can do that without a calculator. Is that making sense? Let's try another one. The rest of this section is pretty much just practicing that unit circle. That's what it is. All right, try that one. Tangent. That's the same place, by the way, isn't it? That's 90 again. Pi over 2 is 180 over 2. So that's 90. So draw the unit circle. It's the same spot, which is over 0, up 1. Remember, this is cosine sine. Now, maybe what you might or might not remember is what is tangent? How do we get tangent? On the unit circle, all I gave you is a bunch of sines and cosines. How do I get tangent? Anybody remember? I think we did it last week, didn't we? Yeah, sine over cosine. Maybe you know that from an earlier course or something. I don't know. I don't remember if I said it or not. It's sine over cosine. Tangent is sine over cosine. So you want to know that long term. That comes in handy a lot. So tangent is sine over cosine. So that's going to be 1 over 0. Like that, right? at 90 degrees, the sine is 1, the cosine is 0. And what is 1 divided by 0? It's undefined. Yeah, you get your calculator? Try it, it'll give you an error. Or say undefined. The expression is undefined. Yeah, it's important that you know 0 over any number is 0, but when 0 is in the bottom, it's undefined. Undefined. Why? Well, because think about any like 0. You think about what a fraction means. If I said last night I ate 1/3 of the pie. I was so hungry, I ate 1/3 of the pie. We all know that's, what that means. If I said I ate 0/3 of the pie, what would that mean? That's a weird way to say you ate no pie, huh? But what would this mean? Remember, a fraction, the bottom goes into the top, right? Like think about 8 over 2. What does 8 over 2 equal? 4, because 2 goes into 8 4 times, huh? That's right. So then think about, again, what would 3 over 0 mean? Well, how many times does 0 go into 3? Infinite, huh? 0 can go into 3 forever. Never fill it up. That's why it's undefined. It's not a number. That's what we mean by undefined. It's infinity, basically. Does that make sense? So 0 in the bottom, 0 goes in infinite. But 0 in the top, like 0/3, that's a 0, isn't it? So 0 underneath, undefined. Remember, under, if that helps. So anyway, the tangent of 90 is undefined. Try to calculate. You guys have a calculator? Hit tangent 90, give you an error. That's how it'll... some fancier calculators might say infinity, or if you have a real fancy one, it might say infinity. But usually they just say error or undefined or something like that. All right. Okay, yeah. So anybody heard about how you know in the various quadrants if sine, cosine, or tangent are positive or negative? Anybody know about that? All students take calculus. Have you heard of that before? It's not really true. But all students take calculus. Let's just do it that way. This is a way to know whether sine, cosine, or tangent are positive or they're negative in the various quadrants. So it's a saying that everybody uses. All students take, you do it counterclockwise just like the quadrants, right? This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So you go just like that. All students take calculus. And what it means, this means all 6 trig functions are positive in the first quadrant. All 6 of them, sine, cosine, tangent, cosecant, secant, cotan, all 6 of them are positive in the first quadrant. In the second quadrant, what do you think S stands for? Sine. Sine is positive. And his upside down, which is cosecant. And the other 4 are negative. So that's what that stands for. Sine and his upside down, they always go together, are positive, and the other 4 trig functions in the second quadrant are negative. Third quadrant, what do you think T stands for? Tangent, and his upside down, cotan, are positive, and the other 4 trig functions are negative. In the fourth quadrant, what do you think C stands for? Cosine, and his upside down, secant, are positive, and the other 4 trig functions are negative. So it's just a really convenient way to know whether a trig function is positive or negative based on which quadrant it's in. So here we go now. They're saying, name that, we're playing a game here, name that quadrant. Tangent, they're telling me some hints, 2 hints about which quadrant I'm standing in. Tangent is greater than 0. Greater than 0, what does that mean, greater than 0? Positive, right. That's a way of saying positive. Are we good with that? If something's greater than 0, it's positive, isn't it? And cosecant is also positive, greater than 0. They're telling me, hey, both these are positive. Tangent is positive. What does it mean? If it says all students take calculus, and this is where they're positive, right? All positive, sine positive, tan positive, cosine positive. If they're telling me first fact, tangent is positive, right away I'm either in the first or the third, huh? Because they're all positive here, and the tangent is positive there. I could not be in the second because only sine is positive, tangent is not. Could not be in the fourth, only cosine is positive, tangent is not. So I'm either first or first or third.
How did you know that they were positive?
Greater than 0.
Oh, okay.
Yeah, so when they tell me greater than 0 here, that's another way of saying positive, isn't it? Bigger than 0 means positive. Less than 0 would be negative. If I said I got less than $0, I've been there in my bank account. That means I'm negative. I'm in debt, right? So if the temperature is less than 0 in Minnesota in January, then it's negative. All right, greater than 0 is positive. All right, and now, how do you know which one it is, first or third? Well, then they tell me this fact. Cosecant. Now, cosecant, that's weird. What's his upside down that we're more familiar with? Sine. That's the same thing as saying sine. So to have that in your 3x5 card for the exam next week, so you know cosecant, sine. They're upside down of each other. So cosecant positive, which means sine's positive. So if sine is positive, where am I? First quadrant. I can't be here. Can't be in this one because tangent's positive, but sine is not. He's only positive there. So I'm in the first quadrant where all are positive. This must be a first quadrant. Let's try another one. Okay, so try that one. Don't say the answer out loud. Give everybody a chance. All students take calculus. Take this fact. Tangent less than 0. And then use the other fact also and figure out which quadrant you're in there. Okay, so let's see. Okay, tangent is less than 0. What does less than 0 mean?
Negative.
Yeah, tangent is negative. So tangent negative, so we're not here and we're not there. Right? Because everybody's positive here and tangent's negative, so we're not there. And tangent's positive here and they're telling me tangent's negative, so we're not there. So we're in one of those other two. And here, cosecant, what's that? That's sine positive, right? Cosecant's upside down on sine. So sine is positive, so we're in the second quadrant, aren't we? 2. Quadrant 2. Good? Making sense? They're telling me sine of theta 7/25 theta is in quadrant 2. Let me rewrite it with some more room. Sine of theta. Quadrant 2, did I get that right? Yeah. Quadrant 2. Okay. All right. Are you ready? We're doing a lot of firsts here in the beginning. So this is something we're going to do a lot of throughout the course. You'll get super comfortable at it. We'll do it a ton. But probably the first time it'll seem confusing. There's a lot of details. But you'll get used to it in time. So I'm going to have to do this big deal here to solve this problem. I'm going to first off I'm going to have to make a triangle, use the Pythagorean Theorem, and then use SOHCAHTOA all together to find the answer to this problem. The sine of theta is 7/25. We're in quadrant 2. So first off, this is quadrant 1, 2, 3, and 4, right? So I'm going to draw my theta angle in quadrant 2. So here we go. I'm going to make a triangle in quadrant 2. Start at the origin. Y'all see how I started at the origin and I'm going in quadrant 2 because they told me to. I started at the origin. In other words, what I didn't do is this. Watch y'all. Don't go like that. Go, okay, there, I got a triangle in quadrant 2. That is a triangle in quadrant 2, but for reasons which we don't have time to get all into now, we'll talk about later. You want to start from the origin. You want to make it from the origin. Okay, now, there's one other pitfall you want to watch out for. You don't want to do that. Why? Because that goes to the y, that's the y-axis right there, right? And this is the x-axis. You do not want to hit the y-axis. I'll explain more. You want to go there like that. That's the kind of triangle you do want to make. Why? What's the big deal with the y-axis? It's a long story, which I'll get more into later. But let me just say this for now. The angles started at 0. Remember, they arbitrarily decided to start 0. They could have started straight up. At the x-axis. Therefore, all of our triangles and other quadrants must be made to the x-axis or the trig functions won't be the same. It's called reference angles. We'll talk more about it later. But for now, just know you've always got to go to the x-axis because that's where everything originated. X-axis 0. So I'll give you actual more specific reasons later. But for now, just go to the x-axis. So start your triangle from the origin and make it to the x-axis, never the y. Where do you put your theta? Can you put it up here? No, you always got to put your angle at the origin. If you do all these things, then all the trig functions will work out. Details later. So there we go. So that's the first thing you do. Make a triangle in the second quadrant hitting the x-axis. A right triangle. This is a 90-degree right triangle. Okay. Now.
Theta always goes
at the origin.
Okay.
Yeah, at the origin. In other words, not anywhere else in the triangle. Now, remember SOHCAHTOA. We're always using SOHCAHTOA. So this is sine, which means opposite over hypotenuse. Opposite over hypotenuse. So from theta, this is the hypotenuse. This is the opposite side. This is the adjacent side, isn't it? So this is 7 over 25, isn't it? See how I put that in the triangle, the opposite and the hypotenuse? Because that's what sine is, opposite over hypotenuse. They just made up SOHCAHTOA like everything else. So now, how do I find the other side, this side down here? Pythagorean, a squared plus b squared is c squared. So a squared plus b squared is c squared. When you use the Pythagorean, we'll use a ton of it in this class, all that matters is which one is c. A and b, the order doesn't matter at all. They're interchangeable. Just get c right. Which one is c always? The hypotenuse is always c. That's the biggest one, right? So it makes sense they add up squared to be him squared. So the other two, whether you call this a or the other one a or b or whatever, doesn't matter. You could say a squared plus 7 squared. Or 7 squared plus b squared. Whatever. Doesn't matter. And solve. So use your calculator, 49 if you need to. 49. B squared, 625. What do you do next to solve for b?
Subtract 49.
Right. Subtract the 49. And so the b squared, is it 576?
Yeah.
And then root it, huh? Isn't it 24? I've done this problem probably a million times. 24. Well, 576 comes up a lot. You'll see throughout the course. So the root of it's 24. You'll probably have it memorized by the end of the course. 24. Okay, so I put that in the triangle. I was finding that other side, huh? I now know it's 24. Okay, so what? Well, now that I have all three sides of the triangle, I can find any trig question they want to ask me using SOHCAHTOA. I think they want all 6, don't they? So, okay, so now I can find all of them. So I've already given them, they started me with sine. So now I can give them cosine. Come on down here. So cosine of theta, what's cosine? Adjacent over hypotenuse, which is 24 adjacent over hypotenuse 7. Tangent is TOA, opposite over adjacent, so that's what, 7 over 24? Wait, did I mess up on cosine? Yeah, I did. I didn't do the hypotenuse down there. You guys just got to speak up. Am I talking to myself here? Were you just thinking, uh-oh? Yeah, I do that every now and then. Let me know. Yeah.
Since it's in quadrant 2, do we have to say that they're negative?
Oh, yes, good job. Thank you. I do need to fix that. I'll show 2 ways to fix that in a second. Everybody good so far? Before I get into the signs, yes, you're right. Thank you. So everybody good so far with generally what I'm doing. So what did I do? They gave me sine of theta 7/25 in quadrant 2. I drew a triangle in quadrant 2 going to the x-axis. Did sine is SOHCAHTOA opposite over hypotenuse, put 725, used Pythag, found the other side is 24. Now I can get cosine. SOHCAHTOA, cosine is adjacent over hypotenuse, 24 over 25. I messed up at first. Tangent is opposite over adjacent, so that's 7 over 24. Yeah, but I'm forgetting about the plus and the minus stuff. Yeah, they're not all positive like I have them right now. Well, how do you know what they really are? There's 2 ways you can do this, whichever you prefer. You could just look at the real life place you're at and think about right is positive, left is negative, up is positive, down is negative, right? So therefore, this 24 is actually negative 24, and the 7 is actually positive, right? Because it's back 24, up 7, isn't it? From the origin. Starting here at the origin, you go back 24, up 7. So it's a negative 24 technically and a positive 7. And we always just leave the hypotenuse positive because that's a radius length. Does that make sense? So wherever the 24 is, he's supposed to be negative. So this is supposed to be negative here. He's supposed to be negative there. Does that make sense? Now, if you'd rather not mess with that, right, up, down, left, positive stuff, you could just do the all students take calculus thing. So my own daughters liked when I showed them all this stuff a couple of years ago. I always tell the girls it's right, and then they go, Dad, we just do the all students take calculus. Sure, that'll work fine. So the all students take calculus. So that means we're in the second quadrant. So you know sine is positive. Sine is positive. And his upside down, cosecant, the other ones are all negative. So it makes sense. Sine is positive. The other ones are all negative. You just do that. That'll work. All right, now those are the first three, and you know how to find the other three, right? Flip it, flip it, flip it. Don't change the signs. So that would be so the upside down cotan would be negative 24. It doesn't matter where the negative is, right? Negative, top, bottom, front, whatever, it's all the same. Negative 24/7. Upside down to this guy, secant would be negative 25/24. And upside down of sine would be cosecant 25/27. Done. We good? Questions on that one? So we'll do that a lot of times in the class. That's just the first of many. You'll get more and more comfortable. All right, so let me get a fresh screen. Remember, tangent is negative 2/3 sine greater than 0. This is number 8. Okay, tangent is negative 2/3 sine greater than 0. Okay, so there we go. Try that one. So first thing to do is draw yourself an axis system. They're being a little more subtle on this one. They're not telling me which quadrant I'm in. That's the first thing you need to figure out. Use the all students take calculus and figure out which quadrant you're in. They're telling you by this hint here. Well, both hints. You need both hints to figure out. Remember, it's all are positive. Students take calculus. That's where the trig functions are positive. The others are negative. All students take calculus. So think for yourself, which quadrant are we in? Tangent is negative. Sine is greater than 0, which means positive, huh? So we're in quadrant 2 again. Does everybody see we're in quadrant 2 again? Because sine is positive, sine is positive. And why aren't we in quadrant 1 where everything's positive? Because tangent's negative. So we're not in quadrant 1. And sine is positive. So we are in quadrant 2. Can't be in quadrant 3. Tangent would be positive. They told me it's negative. Can't be in quadrant 4. Cosine's positive. The others are negative. That means sine would be negative. They told me sine is positive. So we're in quadrant 2. So we're in quadrant 2. They gave me just enough information to figure that out. So go ahead and draw your triangle in quadrant 2. Use SOHCAHTOA. Let me give you a second to figure that out. Start from the origin. Always go to the x-axis. Put your angle at the origin. So remember SOHCAHTOA. So you know what I mean? So tangent, TOA, this is opposite and adjacent, isn't it? From the TOA fact. So in this triangle, this is the adjacent side. This is the opposite. This is the hypotenuse. So put into that triangle. And you can, if you wanted that negative sign, if you want to just skip it, you can just skip it. That's what my daughters always did. The negatives bug them. So they would just put a 2 and a 3 in the triangle, and you can work out the signs later with the all students take calculus thing. If you want to just ignore the pluses and minuses, there's too much to worry about. You can just ignore them, or you can put them in, whichever way. So the opposite side's got to be a 2. The adjacent side has got to be a 3. And then how do you find the hypotenuse? The Pythag, yeah. So the opposite, this is a 2. This is a 2. This is a 3, right? Opposite is 2. Adjacent is 3. Tangent is TOA. So now do the a squared plus b squared is c squared. The Pythag. Find the hypotenuse. It's going to be a root number, isn't it? 2 squared plus 3 squared. The c is the one we're looking for, the hypotenuse. So what's that? 4 plus 9. Root it. So c is root 13. Just leave it that way. Don't do a decimal. They want you just to leave it that way. Root 13. Good there. We've got the root 13. Now you can find all the trig functions, right? So start with sine. Find sine. Find cosine. If you want to put in the pluses and minuses, you could. If you want to just do the all students take calculus, you can do it that way. One way or the other, make sure you have the right signs in the end. Give you another second. So sine of theta, what is the sine? Opposite over hypotenuse. Opposite over hypotenuse. 2 over root 13. Now, by the way, we can't leave a root 13 in the bottom. Remember how in algebra, they never want you to leave roots in the bottom? What do we do to get rid of that root 13? Multiply top and bottom by root 13. Remember that? We did some of that last week, huh? And what's root 13 times root 13? Plane 13, isn't it? Remember, 2 roots make 1 plane. So there's the sine. Now, and let me do the cosine. Now, it might be negative. I don't know. I'm going to worry about that in a minute. Cosine, let's do cosine. What's cosine? Adjacent over hypotenuse. Adjacent over hypotenuse. 3 over root 13. Again, get rid of the root. Multiply top and bottom by root 13. 3 root 13 over 13. Good. Got sine, cosine. They gave me tangent in the beginning, so don't need to find that. And then just flip it. But let's do the plus or minus thing. Let's figure that out. All students take calculus. So we're in quadrant 2. Sine is positive. The others are negative. So sine is positive. The other ones, this guy's negative, and tangent, yeah, sure enough, it is negative. They told me that from the beginning. Does that make sense? You just do it that way. Or, on the picture, you could say, well, I knew that, because this was back 3. This is clearly back 3 up 2, isn't it? Get that out of the way. This is back 3 up 2. So, yeah, that 3 had to be negative wherever he's at right here. That's why that one came out negative. Right. Either way you want to do it. You'll get that truth. And the other 3, just flip it. Oh, when you flip it, let me save some time for you. When you flip the other 3, if I can get this out of the way here. Hopefully you got that copied down. When you do the other 3 and you flip it, let me show you something to save some time. If you flip this one, no big deal. Cotan, negative 3/2, who cares? If you flip this one, cosecant, that would be 13. If you flip it right now, you'd get 13 over 2 root 13. You'd have a root in the bottom, and you got to fix that. And you could do all that. That's okay. But you know what would be easier to save all that work? Flip it from this version. That's the same thing right there. Equal, aren't they? So just flip this one. And the 13, the root's on the top, and you're done. That's what you would eventually get if you simplified the other one. Do you see that? See what I'm saying? If you flip one where the root goes to the bottom, just grab it before you had, right? This is it before I cleaned it up. Just flip that version. Be quicker. If I did the formula, if I took this one, 2 root, and I flipped it, watch, let me prove to you get the same thing. If you did this one, you got, okay, no, I'm just going to flip this one. There it is, and then get rid of the root 13, root 13. You'd get 13 root 13 on the top. 2 root 13s on the bottom. It's plane 13, cancel, root 13 over 2. Same answer, see? Just more work, huh, that way. Flip this one. So the flip of this one would be secant. What's the flip of secant? What's the flip of cosine? It's cosine secant. I'm going to flip this one, because that'd be quicker. Minus root 13 over 3. We found all 6 trig functions. Let's see if we can squeeze in one more. 4 good minutes. We good there? Questions on that one? Hang it up. We're going to do more of this tomorrow, Wednesday. This is not due Wednesday, but 1-2 is due. All right, let's just do the beginning. We're not going to get through this one. But the first couple of steps is really the tricky part. I just want to show you that. So secant is negative. Same kind of thing. Draw the axis system. Find the right quadrant. Draw the triangle. It's the same thing. But the beginning is a little more tricky. That's why I wouldn't show you another of the same type. We've seen enough. But this has got a little extra curveball in it. Let me give you just a second, and then we'll stop here in about 2 minutes. Just do what you can. First off, figure out which quadrant, right? With all students take calculus. All students take, that's where the trig functions are positive. They're telling me secant. Secant is upside down for which one? Cosine, Cosine is negative, right? Negative 11 is negative. So cosine is negative. And tangent is greater than 0, positive. So tangent's positive is quadrant 3. Yep. We're in quadrant 3. Everybody good there? Why aren't we in quadrant 1? Everything's positive in quadrant 1. Cosine's negative, so we're not in quadrant 1. Not in quadrant 4 because cosine's negative. We're not here because sine's positive, but cosine would be negative. So we're in quadrant 3. All right, so now draw a triangle. I just want you to do the first step of drawing the triangle and getting the 3 sides. That's the hard. The rest is the same. We don't need to do that. Oh, by the way, see how I went to the x-axis again? I didn't go over here to the y, did I? Always to the x. So and then put your angle at the origin. Everybody see that? I put the angle at the origin. My triangle came out of the origin. And I made my triangle go to the x-axis. Always the x, because that's where the 0 degrees started. More reasons later. All right, now just do the first fact. Secant minus 11. I wonder if you can handle that. Let me let you put that in the dust. A little more tricky than the other ones. Just put that in the triangle. I know you could do the rest with the fag and everything. SOHCAHTOA. SOHCAHTOA is always what we're using, right? SOHCAHTOA. Now, secant is not one of my... SOHCAHTOA is sine, cosine, and tangent, not secant. So what do I do with secant? I change it, What's secant's upside down? Well, what's the name of the trig function that sits upside down? Cosine. You probably don't have those memorized yet. Put those in your 3x5 card. Cosine and secant are upside downs of each other. You will need to have that in your card, or you'd be dead in the water right here if this was on the test next week, right? You need to know secant is upside down to cosine. Put it on your card if you don't memorize it yet. And what's cosine? If cosine's upside down, if secant's negative 11, what is cosine? What's upside down of negative 11? Negative 1/11. Everybody good with that? I wondered if you'd be okay with that. Flip negative 11, it's 1/11. Negative 1/11. Okay, and that's cosine. Okay, and what's cosine? Adjacent over hypotenuse. So the adjacent side, this is the hypotenuse, this is the opposite. The adjacent side is negative 1, and the hypotenuse is 11. And the rest is the same. Is that okay? The rest, I'll just go dot, 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 do the Pythag, all the rest is the same.